It is live streamed. Yeah, good afternoon to online class. Welcome to the online class. Today we are going to discussing about the second semester of geology. Yeah, here just you can see here it is providing the content page. The contents which are having four blocks we have. Yeah, this block one. You see here crystallography. It is explaining about the formation of a crystals and the classification of crystals. And here we are going to discussing about the definition of crystals in a particular crystallography. And the second unit, it's teaching about the different classifications of crystals. These crystals we can see in the formation of different rocks. Uh, the classification is known as one, it is isometric. Second one, it is tetragonal. Third one is orthorhombic systems. And the third unit is speaking about micro monoclinic, triclinic, and hexagonal system. So here the first unit completely speaking about the crystallography. Different crystal models are there. In that particular point of view, the crystals, how they are going to be formed, and the classification, how it was done in different crystals, those we will see here. The various parts of a crystals also we can see. One, the parts of a crystals we can see at the crystals, and as well as the symmetrical part of crystals and the crystal forms. Different forms are there in a crystal, and those also we can see. And the crystal intergrowth, that's also we can see. The intergrowths of crystal structures, those will be also we can see. And uh, describe the classification. Here we can have a chance to describe the classification of the crystals. The word, first of all, how the crystal it was formed, where the word was extracted. Actually, the crystal it was extracted from Greek word. The Greek philosophers observed the solid material on Europe mountains. That's maybe a alpine mountain. The alpine mountain it is made up of different rock formations. Those they have identified the substances which are formed by the different uh, rock compositions, and as well as it is looking into the very transparent technique, like a glass material they have been identified. Okay, sometimes they have seen the different formation of a luster, and the luster vitreous, that is also they have identified. and as well as the crystal safe crystal, it is looking into the uh, reflecting, and sometimes we can see it is as a is clear images. In a photograph, they have seen a clear images. But how you can define the crystal? The first important it is that one. How you can define the crystal? The crystal it is forming as an inorganic substance first of all. It has a definite chemical composition and which is forming naturally. That means natural substances can define like this: the crystal which is forming in inorganic substances, and it has a definitely chemical composition, and it has a crystal structure and crystal system. Definitely it has a definitely crystal system. So based on these properties we can define the crystal. So first the which is forming on inorganic substances, like example for if you can see the any mineral. The mineral composition example for if you see SiO2. SiO2 Si it is a silica and oxygen it is a gases. So these based on these two compositions which is forming the quartz composition it is a SiO2. So here there is no adding of a carbon material in this one. So here completely it is an inorganic substance, and definitely it has a structure. It has a structure, and definitely it has a crystal system also. So according to that, which is forming. So here, that's only just I told you that is only just example for that one. So we can see the different parts of the crystals also, different parts of the crystals also here. Okay, those we can see in a crystallography. In next class, I'll explain detailedly about crystallography in that. And today we are going to discussing about this content page. What are the topics we have? That's we see today. And later in the next class, I can explain all these topics very detailedly. Because of first, we have to get something knowledge about crystallography, how we can explain that. So directly, if I can say the class directly, we are unable to understand. So that is my intention is that to explain each and the topic very clearly. So that is the reason today we are going to discussing only the description of units. So the crystallography, it is useful for to study of a different crystals. The crystals, how they are formed, the crystals will form it. First of all, it is an inorganic substance and inorganic composition, and it has a definite chemical composition and definite crystal system, and it is formed naturally. It is formed naturally. So here, the science it is known as a crystallography. The study of a crystals is known as a crystallography. And second unit, it is speaking about different classifications are there. The classifications, actually seven classifications are uh, divided. One, it is a isometric. Second one, it is a tetragonal. And third one, it is a ortho. Here, in a part of a crystals, actually, it has some axis. They will travel the axis through the corners. So according to that, you can divide the different parts through the axes. So suppose just you can imagine all the axes you can imagine only here. You are unable to see these axes in a crystal. So these are all you can imagine. You can imagine that. Just I'll show you that. Wait. Just you can see here, yeah, these are the axes. You see the first picture here. I hope you are able to see. This is the PDN it is showing. And okay, you can see here this is a pinacoid and dome, sphenoid. These are the various types of structures are showing here. But just you check it. These are the axes are there. These are the imagined lines. From these imagined lines, these imagined lines are called as axes. These axes, based on these axes, we will classify the symmetrical systems. We will classify. So just we'll go back and I'll tell you. Yeah, you see here the crystallography. It is a study of crystal shapes based on the symmetrical. The symmetrical means the symmetrical axis. The symmetrical axis, what I have shown you just now. And those axes, according to that axis which is divided, the shapes will be also defined based on that only. And the axis here, atoms will be combined to one geometric shape to the another. And based on that scale, so we can divide that is the smallest to the largest. Yeah, some of the symmetrical functions also we can see. The symmetrical functions which are present on crystal of a mineral, which is allows crystal. Based on that, we can classify into the 32 classes into the 7 crystal systems. Okay, those are you see here. The triclinic based on the crystal system, we will divide into the 7 types: triclinic, monoclinic, orthorhombic, tetragonal, and hexagonal, and isometric. These are, and later I'll tell you detail about this. Okay, uh, the crystals we can divide it into the based on the imagine lines. Those will be passed through the different corners and mid of the crystal also. I'll show you that. The axis also which are having a 2 or 3 or 6 axes is reverse. 6 axes also according to that. We see here just you can see this is a pyramid and dome. The lines which are passing through this central, mid, central. This axis is A, B, C. A, B, C. These 3 axes, in all the cases, we can see the 3 axes, and in some of the crystals are having the 4 axes. Some of the crystals are having the 4 axes. So the passing of axes, whether maybe which are having the same equal length, so that we will call the axis A is equal to B is equal to C. and it is equal to 90 degrees. Sometimes what is happening, it is not passing through the anyway, which are passing through the corner and the center, but the axis lengths are not equal. So that at the time we will see, or we will call that is A is equal to B, not is equal to C, and not is equal to 90 degrees. Maybe sometimes it is not equivalent to the 90 degrees, or sometimes maybe it is equivalent to the 90 degrees. So according to that, we will classify that. Okay, these classifications, so we will speak later. And yes, you see again, we'll go back. Yeah, this is. So, according to that, here the crystallography, it is speaking about the formation of a crystal. It is formed very naturally, and definitely it has a uh, chemical composition, and it is forming naturally, and it's made up of inorganic substances, and it is in a solid. It is in a solid formation. So here the crystals will be formed like that, and the study of the crystals are known as a crystallography, and it has a different axes and edges and corners. In a crystal, you can see all the type of shapes we can see, and just you can imagine that the crystal edge, crystal axis, crystal plane, and a crystal center. Through this is the center, and through this is the axial plane, and through this is a corner. Different rays will be passing. Different rays will be passing, and those rays are known as axes. So these axes are known as a crystal axes. So that a crystal, suppose example, a axis it is equal to B, B axis is equal to C, and C axis is equal to 90 degrees. So that we will call that is known A is equal to B is equal to C is equal to 90 degrees of the axis. So based on that, the crystal systems will be divided into the seven systems. Equal axis will be there. Sometimes those are known as isometric, and sometimes only two axes are equal. It is known as a tetragonal, and in some of the crystal system doesn't have a equal. It is known as orthorhombic, and only one uh, only one angle, only one axis it is passing through the center. It is known as a monoclinic, and three which are forming in different angles, and that is known as a triclinic. An hexagonal, it has a four axes. A is equal to B is equal to C, and it is not equivalent to 90 degrees, and it's equivalent to the 120 degrees maybe. So according to that, we will classify that is, and we will call that is known as a hexagonal system. So overall, the first block, it is speaking about the formation of a crystals and the classification of a crystals and classification of a crystals, and it is speaking there. And come back into the block two, and the block two, which is still about mineralogy. The mineralogy. Minerals, different minerals are there, where we can see in a crystals various types of minerals are there. A group of minerals which is leads to formation of a rock. Yeah, how we can define the mineral? The first. Similarly, here also the mineral it is also forming naturally, and it has an inorganic substance, and definitely it has a chemical composition, and it has a crystal system and a crystal system. Definitely it has a crystal system, and it is known naturally it is a farming. Naturally it is farming, and it has inorganic substances. It is known as a mineral. The study of a mineral, it is known as a mineralogy. The study of a minerals, which is known as a mineralogy. And here the first, and again it is also divided into the three units. The one, the fourth unit, it is introduction to mineralogy. The fifth one is classification of minerals. Sixth one is the physical and chemical properties of minerals. So here in first unit, I mean, introduction to mineralogy here. The minerals, how they are going to be formed, and the mineral structure and the classification of the minerals also we can see here sometimes, and the mineralogical characteristics, the physical characteristics, and as well as the chemical introduction of chemical characteristics. Those also we can see here. The physical characteristic like luster, maybe it is a vitreous luster or a glassy luster or pearl luster. Those we can see. Streak, according to the most classification, these physical properties are divided, and we will define these uh, physical properties of minerals. And these are physical properties and chemical properties which are useful for to identify how they are going to be formed, in which rock they are forming, and we will identify according to that physical properties, and based on depend on that the formation we will classify the forms. Different forms are there, and according to that forms we can divide it. So yeah, next one, the classification of minerals. Here the classification of minerals according to formation. We will classify that mineral, whether the minerals which are having the sedimentary formation or sedimentary types of minerals, or depend on their structure. The silica, how they are forming, and the silica, how it is associating with the different different elements. So here you can see the according to the minerals which are classified into the two types. One it is rock forming, and second one it is economic minerals. So here the rock forming minerals may be, it's associating maximum igneous type of rocks, like example for orthoclase, agate, biotite, hornblende, and little amount of economic minerals. Example for hematite, iron ore mineral, and bauxite, alumina type of mineral, and galena, zinc type of mineral. These we can see. These minerals we can see, and we will extract the different economic minerals from above mentioned minerals. So here we see the rock forming minerals, and as well as the economic type of minerals we see here in a rock classification. And as well as in this case, the primary and secondary minerals also we see. The primary minerals, how they are formed, and the primary minerals actually at the time of a product of a magma consolidation. That means whenever the magma, if it is reached to the surface, and at the time the different uh, elements which are formed in that one, and primarily they will form. Primarily means the time of the magma when it is a consolidated, or when magma it is reached to the surface, and at the time at the time the magma while it is getting the crystallization, uh, at the time only these type of minerals will be forming. So that those minerals are known as a primary mineral. And later stage, in second stage, after completion of these primary mineral formation, and later slowly the secondary minerals will be forming. So it can, which is having some processes in the formation of magmatic bodies. Like example, for if you see the quartz, it is, we know that quartz it is a primary mineral. And sometimes what is happening, the quartz it is associating with the malachite also. Malachite means here the copper associating mineral. It is forming in the second stage along with the quartzite, along with the quartz. So that here, not only that one, just you can see here BMQs also. BMQs means banded magnetic quartzite. Here the quartzite will be forming, and later stage the iron it is slowly replacing in the in the presence of a quartz. So it is forming in the form of a band. So that it is known as a banded magnetic quartet, because of the magnetic is a forming in the form of a bands along the quartet. That is the reason we will call that is known as a PMQ. So it is forming a secondary. The first formation it is a quartz, and along with so that we will call that is known as a primary mineral. But later stage in a BMQ, the iron will be forming along with the quartzite. It is called as a secondary mineral. So like this here, the primary and secondary minerals will be forming, and we will classify like that. In the primary stage, while the magma it is getting consolidation at the time of mm, consolidation of a time consolidation at the after completion of that one, slowly the quartz it is replacing by this uh, magnetite. So in the form of a magnetite, the second stage, in the second stage, it is going to be formed. So that's one thing. Yeah, in a third, in a next chapter, we can see here it is a next chapter that is physical and chemical properties of minerals. In the physical and chemical properties of minerals, that is explained by the sixth unit. We see uh, what are the physical and chemical properties we will study. Here, the physical and the chemical properties means here like a fracture, the fracture how it is look like that, and cleavage. The small parting parts are small fractures or a small line breakups you can see on a mineral that is known as a uh, fracture or cleavage. So here the first property color we can see, second one it is a streak, third one it is luster, your fourth one is a hardness. Here in a hardness we see the mole hardness scale. The mole hardness, the familiar scientist was a mole we was found, and he explained the hardness of the different minerals from the smoothness to the hardness. So he has categorized uh, 10. He gave numbers 1 to 10 numbers. One it is a tall, second one it is a gypsum, third one it is a calcite, fourth fluorite, yeah, fifth apatite, sixth orthoclase, seven quartz, eight topaz, nine corundum, 10 diamond. So now you check out, you get the from a tall canvas to the upper diamond slowly, it is going to be the hardness going to be increasing. The hardness it is increasing. So that is a reason based on the hardness the minerals were classified here. So this is the scale. It is very important. I'll tell you in a later class very detailedly. Yeah. Next property it is a cleavage. The cleavage it is also one of the diagnostic and physical property. We can see the you can define the tendency of a mineral or a small splits or small breakups we can see on a mineral. Like example for you can see on a calcite and a calcite we see the small scratches on the surface. And as well as orthoclase also we check and check out the orthoclase feldspars, which is we can see that is in a flesh red color or a light pink color. We can see that is also in that is also the surface of orthoclase minerals. It is orthoclase minerals. It is also having small scratches on a surface. So these small breakups or small splits we can see on a surface. Those are known as a cleavage. So that's one thing. And second one, next property it is known as a fracture. The fracture means breaking. The cleavage is slowly the breakups what we have identified on a surface on a mineral surface. Slowly it is extending those breakups. So it is look like as a fracture. The cracks will be extended. So we will call that is as a fracture. So that's the one thing. So here, that's also one of the property we can see. And tenacity also we see. And next property it is form and the structure. Different forms are there, like foliated, granular, fibrous, columnar, rosy, dendritic, reniform, oolitic, banded. These are all the forms. Different forms are there on in a different minerals. And finally, we will identify the what it is a mineral. And occurrence also we see here. the occurrence, the formation where we have identified these, and the origin also we can see in a physical property. That's something. And some of the minerals are having showing the different formism. That's a pseudoformism, polymorphism, isomorphism. These we can see depend on their formation. Specific gravity also will calculate the specific gravity, the amount of water, how much it was absorbed, and what it is the volume of that mineral, and weight. We will we will find out the weight, and that weight, the percentage of a specific water amount we can see, and at the same time we will calculate the specific gravity for the same. So these are the characteristics we can study in a physical properties. And chemical properties means here we see the definitely the chemical compositions. What are the chemical compositions are there? What are the atoms and the molecules or elements were formed? Elements were for how? What are the conditions are required for the formation of different elements? Whether it is belongs to the clay minerals or hydrogen minerals or maybe phosphate minerals or whatever it is that. So different minerals are there. The different minerals we can see and we can study. So uh, based on that availability of and formation of minerals, we will study. The next block it is mineral families. Yes, there are different mineral families are there. The availability of a silica and formation of a silica, whether the silica it is uh, quietly it is absent, or maybe it is participated a huge amount of a silica in formation of a different minerals. So according to that, we will classify that whether the minerals are belongs to the uh, silicate minerals. Based on that availability of a silicate minerals, we will call whether it is nesosilicates, orosilicates, cyclosilicates, and uh, inosilicates. So the availability of or formation of a silica. Based on that, the formation of a silica, we will classify whether it is a tetra group or hexa group or whatever it is that according to that, we will classify those silica group of minerals and we will classify. Maybe it is a chain silicate or ring structures, um, structures or pillow structures. According to that, we will classify. So here, the unit seventh is speaking about the nesosilicates, orosilicates, cyclo, and inosilicates series. Unit 8, the phyllosilicates structures, sheet-like structures, or chain-like structures. Those structures we can see you in the next unit. And some of the non-silicate minerals also we can see, like example for sedimentary formation of minerals, like the clay or organic structures, carbonated minerals. Those we see here. Um, Phosphorus minerals, and those minerals we can see here. We will study here. And final, the block it is known as a optical mineralogy here. In the optical mineralogy, particularly, we'll study the optical properties of different minerals and what is the scope and how it was developed and how we can develop the optical minerals is uh, in naturally how they were formed, and we will identify what are the optical properties are there in a particular minerals, and those we will study in the microscopic and some of the and microscopic, and we see the microscopic studies under the microscope. We will investigate the different minerals under the microscope, and we will check out how we see the here the physical properties of the same the minerals what we have identified. So here the description, Unit 10, it is a scope and availability and development of optical minerals. We will study. Uh, and Unit 11, we see the description of a polarizing microscope. Here we see the polarizing and non-polarizing minerals. Some of the minerals we can see under the natural light, and some of the minerals we can see the polarized light. So here the reflection, what is the reflection of those minerals we'll study, and maybe sometimes we see it has a double refraction of minerals, and some of the minerals are not showing their properties in the presence of a double refraction. So what is the differentiation there? Just we can see. And under the nickel prism, the polarizing microscope, we see the 10x or 20x, or maybe it is a 40x or 100x. Those the minerals we can see under these type of lenses, different lenses we can use here. And the microscope, the mechanical parts of microscope also we can study here, like a stage, tube, objective holders, and contouring screws, adjustment devices, stage, substage, and optical parts like a mirror or a diaphragm. These properties we can see, and as well as we see the procedures and operations also there. The procedures and operations, how we can operate, and what are the procedures. There are some procedures are there. If you wanted to study the microscopic slide. So here we will make, and we will arrange the things according to that. We will make first we will make a slide, the rocks slide. Suppose if you are selecting the igneous rock composition of a slide, how to make it that. That's we need important. We'll convert into the small powder, and we will fix the Canada balsam, and we will cover the Canada balsam, the material under that material, and we will cover with a small cover slip, glass cover slip on a slide. And now we will dry it with using of a different temperature. Under the temperature, we will dry it, and we will make that slide, and you can keep under the microscope. Microscope, so the light will, how it will be entered into that microscope, and the stage we will rotating. Once if you were keeping that my slide on stage, now you can rotate to the same same slide, and different. It is showing the different colors under the light. So the colors we can need to note. So the color it is exhibiting different minerals are exhibiting the different colors. So that according to that, now you will find out here whether it has a cleavages or not. While we are rotating on your stage the mineral under the microscope, now you can observe these things, whether the color, whether it is exhibiting or not, the grain sizes, or maybe the grains are having the euhedral shape, subhedral shape, and anhedral shape, and it has any cleavages or any fractures and interferences, and interferences in the polarizing and non-polarizing light also we see that. So these properties we can estimate, and we will examine, and finally we'll get some output whether the mineral it is belongs to the silicate mineral or belongs to the which type of a mineral. Now we can find out, and according to that we will find the location and occurrence also. Next, the final unit, it is known as optical properties of minerals. Here, in the optical properties of minerals, we see here the ordinary light. Under the ordinary light, we see here the color form, whether it has any inclusions. The mineral way, maybe if it has inclusions, while you are rotating, it is showing the different colors if it has inclusion. Maybe if it doesn't have any inclusion, it is not showing the any the colors. Any different variations, it doesn't show. Uh, Plain polarized light, here we see the plain polarized light. In the plain polarized light, pleochroism and non-pleochroic halos we can see. Yeah, later I can explain about these halos, but only just think it is a pleochroic and non and pleochroism halos we can see. Pleochroism means while it is rotating, it is showing the different colors. The property it is known as a pleochroism. So some of the minerals are not showing. Just example, you it is a quartz. The quartz it is showing different colors while we are rotating, and whereas you can see in a zircon, but it's showing only one color. Even though if you are rotating that, it is showing that. So there is a variation there in the pleochroism. Some of the non-pleochroic minerals doesn't show any color. Example for the calcium carbonate, the limestone, it doesn't show any color. While you once if you are rotating uh, the complete rotation, it is also showing the same color. So that here we can see these type of pleochroic colors. And refractive index also we can see here. The refraction in at what stage it is showing the refraction. The index we need to identify. That's also we need to study. And twinkling and the twinning process. There are two methods. There are two properties are there. One it is the twinkling, and second one it is the twinning. Uh, in a plain polarized light, only it is showing the twinkling. It is showing the twinkling. Or whether we see the twinning party in a cross Nichols. In a cross Nichols, we see here isotropic or anisotropic, and will also be studied. Different intervals also in see. Any alterations are there or not, we can see. The minerals which are alteration means here the changing. Here it is changing the original formation, and it will be showing the color because of while it is coming to from the deeper level of earth coming to the surface, it is accumulating and mingling the different minerals when it is originating. So that now after cutting up that one, the same material will be remain in that slide slow. So that is the reason it is showing. Yeah, it's showing the alter. It is showing the different mineral property here. The property it is known as here altered. The chemical composition will be also different from the words. One more property it is here we can see the twinning here. And isotropic and anisotropic substances, we will identify whether it is belongs to the isotropism or anisotropism. It has anisotropism, that's also we need to study. And yeah, few minerals will be we can see whether belongs to we will call that is known as a uni axial crystals or biaxial crystals. Here the uniaxial crystals we see in the same angle. In a certain angle, it is showing the one mineral. In a biaxial veins, once we are rotating in a different angles are showing the different minerals. So what are the minerals are there in that case, or what are the minerals are there in that slide? We will see that we identify what are the minerals are there, and we will have a deep study with them. So these are all the overall description of this one. These crystallography and mineralogy, and we'll study in second. Yeah, we'll study in a second semester, and from the next class onwards, we'll explain.